Okay, today we're going to look at the topic of molarity. So we've been dealing with solubility and this idea, if I have something like sodium chloride and I put it in water, it becomes aqueous or aqueous. And what that tells me is that my sodium ions and my chloride ions split apart and are now floating around in solution. And if we think of what we learned so far in chemistry, there's this idea that, the more of these that are in solution, or the more of these things I have, the more I can react. If you think of a reaction, say we have some simple chemical reaction. We have 2 moles of sodium plus chlorine going to 2 moles of sodium chloride, okay, to produce that or something. If I want to compare how many grams of sodium chloride I can make or something like that, I would need to know how many grams of this I started with, convert to moles. And then once I get to moles, I can come over here and find out how many moles of this I have. So, if I change the grams of sodium chloride, or sodium, then I could change the moles and the grams of sodium chloride that I produce. If I have, 100 grams versus 1,000 grams, the 1,000 grams of sodium chloride, I could produce more sodium chloride. So, now, the problem with solutions, this would be if it's a solid, right? This would be a gas, but with solutions is, well, I can't measure grams of sodium chloride straight in solution, okay? Because if you think of it, if I have this dissolved in water, well, I've also got these water molecules that are surrounding these ions as well, so I can't, that's the wrong orientation, sorry. So I can't just say, hey, 10 grams of sodium chloride is necessarily more sodium and chlorine than 15 grams of another solution, or less than another solution. Okay, so what we're going to deal with, and you guys know this, is we're going to deal with concentration. Okay, different solutions can have different concentrations. Okay, let's say you're drinking some Kool-Aid, all right, and there's fruit punch or something like that, and there's one Kool-Aid that's really, really dark red. Okay. So one Kool-Aid is going to have, really dark color. And then another Kool-Aid, you have an option, has a really faint kind of light red color. Well, which Kool-Aid are you going to pick? The one that looks like really watered down, or the one that actually looks like it has Kool-Aid in it? Okay? So you're going to pick the what? The more concentrated one, probably. All right? So we have this idea that solutions can have different concentrations, okay? But we don't really have a value that is associated with them, or you don't yet probably. You could just say, hey, the dark Kool-Aid has more in it. Well, how much more? So that's what we're going to learn about today, molarity. Molarity gives a value to the concentration of solutions. So, now if we're thinking in chemistry, and the names kind of, part of the words in this name, how do you compare chemicals? Well, you compare them through moles, right? And then we have molarity. So what molarity equals, it's represented by a capital M. Molarity is equal to moles divided by liters. The moles of the chemical divided by the liters of the solution that you've dissolved it in. Well, this gives me a value now. So if I say something is a 1 molar solution, what's that tell me? In 1 liter, so if I have 1 liter of the solution, I have 1 mole of the chemical. So let's say it's 1 molar, let's go back to sodium chloride solution. So if it's 1 molar sodium chloride, if I take 1 liter of that solution, I'd have 1 mole of it. What if it was 2 molar sodium chloride? Well, in 1 liter, I have 2 moles of sodium chloride. Or it's twice as concentrated. There's 2 times as many sodium chloride ions, sodium ions and chloride ions in this solution. Okay, so how do you calculate this? Well, the units help tell me what calculation to do. I'm going to have to calculate how many moles and how many liters of solution I have. So let's do one real quick. What is the molarity if 58 grams of sodium hydroxide is dissolved in 1 liter of solution? Okay, well, so how do I find this? Well, anytime you're doing a solution or molarity, always look back to this equation. Molarity equals moles over liters. You know, you can be given any 2 of these 3 variables and you can solve for the other one. So let's see what I'm given. Well, I don't have these 2. I've got grams and I've got liters. But what do we know? Well, I can convert from grams to moles. So I'm going to take that 58 grams sodium hydroxide. I know in 1 mole of that solution there are 40 grams. My grams cancel out. I can convert to moles. And what I find out, there is 1.45 moles. Okay, now I can just plug that into my formula here. I have 1.45 moles. I know my volume is 1 liter. So my molarity is equal to 1.45 moles divided by 1 liter, which is equal to 1.45 molar. Okay, so as you're solving these problems today, always go back to this equation. Molarity equals moles over liter. And it gives me a way what to do. It gives me a way to tell me how many particles or items are in solution. So, and that's what we want to know in chemistry, right? Because chemistry happens on the atom-to-atom basis. Okay? And how do we count atoms? We count atoms through moles. Well, that's not going to change when you go into solutions. Okay? When we start making solutions and we start acting, doing solution chemistry, it's still how many atoms of this versus how many atoms of that I have. We're just going to have a different way to measure it. Okay? We're going to measure it through molarity. Also gives me a value to compare concentrations straight away. If I have a 5 molar solution versus a 10 molar solution, well, the 10 molar solution is 2 times as concentrated. Okay? So now that's kind of the next step here. All right, there's your video for today. Go ahead and try those online book problems that I'm going to put up. Have a great day. See you guys.